In this video, we're going to look at the last example from the notes in section 1.6. So this is example 4 coming from page 32 on our notes. So example 4 says, in each of the following, you are given a description of a function f. Sketch a graph that matches the description and then indicate where f, f prime, and f double prime are positive or negative. So let's read the description in part A together. So P equals F of T gives the population of bacteria colony after T hours. The population increases and the rate at which the population grows also increases. So I like to start out by first setting up our graph. We're told the population increases. So over time, it starts from somewhere smaller and gets larger. So these 2 points that I just drew sets me up for drawing an increasing graph or an increasing function. Now we're told the rate at which the population grows also increases. So recall from our previous notes, we saw that if f prime increases, then f double prime is positive. And remember, we saw that with if our original function increases, then our first derivative is positive. So again, it's the same pattern that we've seen. And that pattern is the relationship between the original function and the derivative of that original function. So we know in our case that since the rate at which the population grows increases, that our second derivative has to be positive. That tells us from our notes that we're going to have a concave up graph. Also, we can just kind of start to sketch it in. So if we want our rate to grow or increase, then we want our tangent lines to start off somewhere, say here, and then get larger, or rather the slopes to get larger. So we see that that kind of graph is going to have this kind of shape and look concave up. So there's several ways of getting to the same place that our graph is going to be concave up. So now let's just summarize by indicating whether f, f prime, and f double prime are positive or negative. So I encourage you to pause the video and write this out for yourself and then check your work. When you're ready, let's look together. So starting with f of t, well, f of t measures the population. Can we ever have a negative population? Nope. So f of t is always going to be positive. And you can even make a note to yourself of why. I'll do it for us here. So population is always positive. So then what about f prime of t? Well, because our function increases, we're told it increases, the rate of change is positive. Because again, these tangent lines then are all having a positive slope. So that's because the population increases, meaning a positive slope. Then what can we say then about the second derivative? Well, the second derivative is also going to be positive, and that's because the rate of population growth is increasing. So we could say the rate of growth or the growth rate increases, i.e. f prime increases. Use like up arrow to denote increasing, just for some shorthand. Awesome. Cool. That wasn't too bad. So let's look at part B. So part B, we're told that H is equal to F of T gives the temperature in Fargo, North Dakota after T hours on a particular day. The temperature is below 0 the entire day. And although it steadily warms, meaning the temperature increases during the day, the rate of warming decreases with time. So at first it starts to get warmer really fast, and then it slows down. Doesn't get as warm, or doesn't get warm as fast. So what should that look like? Well, we know that we're first of all below zero. So we're going to have our graph be down here. So check first of all. Steadily warm. So that means our graph will increase. So I want to draw my 2 points to know that I'm going to start low and get higher. But then the rate of warming decreases. So if I draw some like ghost tangent lines in here to describe the rate of change of the temperature, we're going to start out with a large rate, so a steep slope, and then our slopes will start to get smaller. So we see that's going to look like this concave down graph. And also just thinking about those tangent lines again, the tangent line slopes decrease in value. So they start high and then get smaller. So that would signal, I'll actually write that down first, f prime decreases. So that would tell us that the second derivative is negative, which also leads to that concave down graph. So our graph, erase too much, our graph would look like the following. So I want you to pause the video and see if you can write out what the consequences are then for this kind of graph that we've just drawn for f, f prime, and f double prime. Are they going to be positive or negative? When you're ready, let's check together. So f of t, just the function, is going to be negative because we're told that we have a temp below zero all day. So it's always going to be negative. But we're told the temperature increases. So the derivative is going to be positive. Those tangent lines have a positive slope. This is because the temp increases. But we're told that rate of increase slows down. So the first derivative gets smaller over time. So that would mean the second derivative, or decreases. So the second derivative is negative. So if double prime of t is less than zero, that's because the rate of temperature slows down, i.e. decreases. And we saw that before, the rate decreases, so the second derivative is negative. Awesome. All right, great work, everyone. Again, I encourage you to rewatch this video, pause, work out the problem for yourself, even try it again. And the more of these videos that you watch, the more of these problems that you do, the more that this work will start to really come together. All right, great work, everyone.